analytics and machine learning will transform education. I'm Jonathan Rochelle. I'm really just going to intro the session. And we've got some great speakers here, as you'll see, who will sit awkwardly while I present. And then we'll move on. So I love to introduce myself as the way I see me, rather than the way you would see me without this slide. But more importantly, I love to show how I actually am seen by my kids using the magic of machine learning. Anybody recognize that? Nobody? Nobody? Snapchat. So, you know, the face thing, and that's the only way I can get my kids to answer me, is if I somehow reach out to them in a way that the machine can transform me into something more interesting than myself. So that's what I do. And it's worth it. It works. If you are trying to reach your kids that are teenagers, try that. It'll work. Get Snapchat just for that purpose. We're going to talk about machine learning, though. So let's start with, what is it? What is AI and machine learning? Let's put it into context. AI, just from a terminology perspective, syntactically, it's the science of making things smart. That's the broad category. And machine learning is a technique used to develop AI. So it is one technique, and it is the one that is right now trendy and well used. When you think about it and how to apply, like, well, what is it? How does it work? Think about how you learned your native language, not a second language, although it probably applies to that too. Somebody, your parents didn't hand you books, obviously. You couldn't read yet anyway. But they didn't say, here, this is how you learn it. Here's the rules. Here's how grammar works. Here's a dictionary with all the words. What you did is you learned by example. Somebody would point to a dog and say the word dog. It was all learning by example. That's what machine learning is about. It's having examples and having data that the machine can use as examples for how to apply those rules and develop rules for the next problem it sees. At Google, machine learning is very prevalent. This is a chart that just shows how our internally developed machine learning libraries that are developed by specific teams of engineers, an amazing group of engineers, develop these libraries, and over the course of this period, you can see the chart just exponentially grows. Mostly started in 2014 a bit, and 2015 just exponential. This is the use of the libraries in other products. So what other products? You see it in photos. If you use photos, and I have to say, I don't work on photos. I work in G Suite for Education. But Photos is probably the single Google product I recommend to people the most because it makes use of what you've got in terms of photos, because I can search for it without tagging it. It understands kids on the beach. I can find the pictures that I'm looking for. It understands. I can look up the word. I once looked up the word bug because I was doing a presentation and clearly I needed to talk about bugs. And unfortunately, it did an amazing job of finding bugs in pictures that I had taken, so therefore no copyright worries. There was one picture of a restaurant, like a dish that somebody took. I didn't look further to see where the bug was, but I trusted that the machine found something. Gmail is another one. You probably saw some of the announcements yesterday. Smart Compose. It's using the machine learning libraries that we've got, the algorithms and the models, to apply it to a problem, to a otherwise rote task of answering very quickly, and it helps us. It helps us in our everyday lives. Forms is another one. I'll go into a little more depth what we did in Forms. The Forms product is also used as a quiz product in education, and we decided it would be really nice if it was easier to make a quiz question when a teacher is working on quizzes. So they can ask a question. They can say, well, who is the Prime Minister of Australia? The machine will say, here's the right answer, Malcolm Turnbull. It'll recommend that. Bless you. And then it'll actually recommend some wrong answers as well, so that this is actually a reasonable quiz, and a teacher can really fly through the creation of this quick formative assessment. But when you look at Google's mission, it's to organize the world's information. You can all recite this probably at this point. You've heard it so many times. And make it accessible and useful. What's our mission in cloud and machine learning? It's to make the technology and the AI universally available, accessible, universally usable by other developers, by so many of the people sitting here, the people in other sessions, learning how to use the technology and the infrastructure that we've developed for our products so that you can apply it in your products. So the APIs are how we do that. Things like Cloud Vision and speech and translation and BigQuery. And those things are being used by others. This is just the one quick example of Airbus using image technology to improve the ability to use their satellite imagery to understand the difference between clouds and snow in images. It would take humans just incredible amounts of time to do that manually. They do it with a machine. So what would be the impact of AI in education? That's what we're here to talk about. And the best way to talk about it is to show examples. And that's what we really wanted to do, is to present examples and have the people doing it present the examples. So we're going to hear from 3 different people. We're going to hear from Mike and from Etienne, not in this order actually, and Lige, sorry. I knew I would get that wrong. So we're going to let them take it away. I'll just quickly, if you're looking to see who's speaking, the 3 presenters that are showing the examples from our higher ed partners along the top, Etienne, Lige, and Michael, and then myself. You'll hear from Tracy after them, and then Stephen will help moderate a Q&A. So if you come up with questions, if you think of questions, hold them, and for the Q&A, we'll spend some time doing that. So let's pass it off. You're mic'd, right?
All right, thank you for the introduction, Jonathan. I'm Michael, and I'll be talking today about how at Carnegie Mellon we're using cloud machine learning to drive our research for social educational AI. So humans are social animals. Decades of research, our own experiences tell us that learning happens through dialogue, through conversations with other people. The kind of questions we ask each other, the way we give each other feedback, and even when we confess that we don't know something. All of this is part of this social infrastructure that gives meaning to learning. So I can still remember my 6th grade English teacher, Mrs. Owens, sitting down next to me and looking me in the eye and saying, "You know, Mike, this essay needs some work, but I still struggle with my writing too." And that moment of connection has stuck with me. So if we know that dialogue is important in learning, why do most of our educational technologies look like this? One student tapping away at a tablet. Well, the short answer is language is complicated. It's hard. So imagine you're tutoring a student, and she looks at you and she says, "I think I know how to do this problem." How do you respond? Well, you might pick up on the cues in her voice. You might pick up on her facial expression and recognize that, okay, she seems pretty confident. Let's let her work and only step in if we need to. But what if she looks at you and she says, "I think I know how to do this problem"? Again, you might pick up on those cues in the voice, and you might notice the furrow in her brow. But if you were to design a virtual tutor to teach a student, how should it respond? Well, one way might be to look at those same cues, the acoustic signal, to train a classifier from their facial expression and recognize that furrow of the brow. But what does it mean? Is she furrowing her brow because she's confused or frustrated, or because she's focusing and concentrating? Or maybe the lights are just in her eyes. So as humans, we have other resources we draw on. We draw on our social knowledge of that student, and we know from working with them how they respond to hard problems. Well, commercial dialogue systems, commercial machine learning, has made a lot of strides in the last few years towards some parts of human language, but in other parts, like the social norms, the cultural norms, these parts of human language that give it meaning, their commercial dialogue systems have some ways to catch up. So in the labs that I'm a part of at Carnegie Mellon, we study how cultural and social factors impact and can be designed into learning technologies. So one example of this, we've been working for the last several years with a university in the Philippines to study how students talk with what's known as a teachable agent. So the students type their explanations to this agent to teach the agent how to solve algebra problems. And the idea being that through explanation and through being compelled to explain their reasoning, students will learn. So what we found, so we deployed this in 3 schools, in Manila and in Davao. And what we found was that students are doing something known as code switching, where they're typing to the agent, sometimes in English, which is the official language of instruction in the schools, and sometimes in Tagalog, Filipino, or even in their local language, Bisaya and Cebuano. But the agent doesn't speak Tagalog. It doesn't understand when they type that. And the students actually knew this. They were told that up front. So why were they doing this code switching? Well, theories of code switching tell us that the context matters, your audience matters, who you're talking to, how you feel about them, the way that you want to build this in-group with another person or keep somebody out. And actually, we're still analyzing this data, but what we're seeing is that students are code switching both when they're frustrated at the agent for not understanding, and also when they're trying to build solidarity with the agent. The agent just made a mistake, and they want to cheer it up a little bit. In neither case, the agent can understand. But so if you were to design a virtual tutor or a virtual agent for a bilingual context like this, how should it respond to this type of code switching? Well, you might need some sort of social awareness to do that. So over the last several years, we've been studying how students build rapport, build this connection, this social bond with each other in learning. And we're finding that it improves their learning. They're learning more, they're more engaged, they're bought into that learning process, especially for an anxiety-producing topic like algebra. But, of course, this rapport isn't always increasing over time. Sometimes things are going well, and other times things aren't going quite so well. So if you're going to model this and design your agent to respond to this, how do you do it? Well, we're using cloud machine learning to design a rapport-aware virtual tutor. That is one that can respond to bids from students to build this connection and respond in turn. So we start by collecting data from students tutoring each other. We have over 100 hours of audio and video data of students tutoring. We use social science theories of rapport building and learning to inform what type of features should we focus on. Then we train our machine learning models using Cloud ML. And we deploy those in what's known as a human-in-the-loop system. For right now, this is a research-based platform that we are running a study on. And Google Cloud Platform allows us to easily train these models, improve them over time, and share them with other researchers in our lab. So we are a research lab at a university, so new students, new undergraduates, new master's students, PhDs come in every semester, and with Cloud ML, they're able to easily get started running models right from the first day that they join the lab. And that's huge for our ability to be productive. So what do we exactly do with Cloud ML? First, we detect some of this social language from the students. So what does that mean? So think about this. If you're giving feedback, right, in that case of that virtual teachable agent, if you want to tell it it's wrong, do you just say, nope, wrong? Or do you do what's known as hedging and soften the blow? So this is just one example. We have a set of other social dialogue that we have classifiers we've trained for. Like that confession, that self-disclosure, I still struggle with Algebra 2, or this is really hard for me. You can imagine a 12-year-old might not want to volunteer that information the first time they're working with a new tutor. We also use Cloud ML to model or classify the current level of rapport. So we've developed in one of our models something known as an attention-based neural network, which cues in on these moments of high and low rapport. So I'll give you an example. If you are all the machine learning classifier here, and you have to estimate a scale of 1 to 10, is this low rapport or high? What might you say? Okay, and we get some distributions there, yep. And for this instance, a little higher, right? Now this is a snapshot. Of course, these are all dynamic processes. We use video and language, and our model keys in on those moments of higher rapport as well and pays attention to those. Finally, we use Cloud ML to reason about or choose the next social language the agent should say. So if the student gets something wrong, rapport is pretty low, and the tutor has to give the student negative feedback, how should they do that? Should they self-disclose, say, I struggle with this sometimes too, or praise, or hedge? And we use what's known as an LSTM, or a variant of a neural network, to hedge and rephrase this. So Google Cloud helps us accelerate our research. Now, it's still early days for this type of social awareness in dialogue systems, but we're using this research platform to better understand theories of learning and ideally improve the learning process. The best teachers know students are more than just information processing machines. Students are social, and learning happens through dialogue. And we hope that our educational technologies will soon start to reflect that. I want to acknowledge our collaborators in our lab and invite you to stop by our booth in the exhibit hall. And with that, I'll turn it over to Lige.
So my name is Lige. I'm the Chief Technology Officer for Ivy Tech Community College of Indiana. Does everybody know where Indiana is? I have to ask that. So Ivy Tech is what I like to say is the biggest school no one's ever heard of. So I'll tell you a little bit about where we're coming from and then tell you some of the things that we do. So Ivy Tech is Indiana's community college for the entire state. We are the 4th largest higher ed institution in the United States. Well over 7,000 employees. We have about 170,000 students every year. And our user base, the folks that we provide services to, is well over 700,000 people around the state of Indiana and around the world. But the important number, I think, for today is this one up here. As an enterprise, we generate well over 100 million rows of data every single day. And the vast majority of that data has to do with students. And so I'll tell you what we do with that here in just a second. So what we do with that essentially is we analyze it for student behaviors. And what we're trying to do with that is predict, if you will, how a student's going to do in a course. So day 11 in a semester, so a semester is approximately 80 or so days, but day 11, we can predict with about 83% accuracy how a student's going to do in the course. A couple important tidbits here. We do not look at attendance. We do not look at grades. We do not look at biodemographic anything. We look at behavior patterns. This entire project here is all based around behaviors. And we do this every single day. So every day of a semester, we reanalyze the data from the last 24 hours, compare that against the 2.2 million students we've collected data on over the years, and then we do these projections out. So another question is, what do we do with that? What we do is we talk to the students, which I know is somewhat of a foreign idea sometimes. So I'll tell you one tidbit. It's called Project Student Success, and essentially what that is we get this list of students on day 11 and we call them. And we text them, and there's other modalities. It just depends on where you're at in the state and a few other things. But essentially, we reach out and talk to them. The first year that we did this, we had over 16,000 students on our list, and we knew these students were going to struggle in their course. And we knew why they were going to struggle. That's another important tidbit. We know the behaviors they're exhibiting that are going to lead to failure in the course. So we knew who they were and what was wrong, what behavior they were exhibiting, so we called them all. Out of all those students that we called, and there were more than 16,000 calls because the students don't always answer the phone, right? Customers don't always answer the phone. There were 4 or 5 students in that group of 16,000 that had their electricity shut off in their home. So we have students from age 14 to age 95. We're a big commuter school. So we have everything you can imagine in our population. So when your electricity is shut off at home, you might talk to your parents, try to get an advance from work, you might hawk your television, but calling your college, in our case, calling Ivy Tech was not high on anybody's list. But it does turn out, being community college for the state, we have a lot of resources. We work with a lot of social programs, community programs. We have an alumni association. We have emergency funds that we can help students with whatever those issues are. But the students didn't know to call us. So essentially what had happened is those students had a life event. That life event manifested itself in our data as an anomaly. We detected that with the AI that we wrote, and then we just called and talked to them. So I can assure you, had we not detected that and talked to those students, they would not have made it to the end of the semester like they did. So that's one interesting little tidbit. But we don't stop there. What this is here, this is our enrollment management folks use this dashboard, and I'll briefly explain what this is. So we have enrollment goals for the year, and if you're in higher ed or in retail, you have sales goals. That's over on the right at the end of May. So what we've got there, the green line is what I like to call the happy path. So if everything goes according to plan, our enrollment will kind of follow the happy path, and we end up in enrollment nirvana, which is what I call that too. That line was generated by the AI that we wrote. So we looked at historical patterns, all the things that we take into account, and we plot that line out. The black line is our actuals, and this is actually from our institution just about a week and a half ago, so heads up, we're a bit behind. But the black line is our actuals, and you can see that we actually followed the happy path as the machine predicted, and then we started to fall off a little bit. The gray line then is a projection on where we're going to end up unless something changes. So at our organization, the president, her cabinet, all of our C-suite, they use AI every day in all of their dashboards and they're looking at. Now, sometimes they know that, sometimes they don't. But this happened about 2 weeks ago. We had a conversation with our COO, and we were making adjustments that were going to happen in May based on the predictions that we know of today. And I've been at Ivy Tech for 8 years. I've never seen that before. But now we're using AI in all aspects of managing the business. A few other fun things that we do. We also have some AI written around retention, so we know months before the end of a semester if a student's coming back. That allows us then to do some maybe more targeted efforts to get those students to come back. That's an issue in community colleges. We have some AI that we've done around fraud detection. This would be financial aid fraud detection. So we have a lot of people that like to do identity theft, and financial aid fraud is a big deal in higher education. Certainly it is for us. So we have some things written there that take that into account. And then finally, we're actually working on, it's not done yet, but we're working on a mobile experience where we incorporate all the AI stuff that we have from the back office and push that out into the students' hands. I won't go into all the detail, but it's really cool, and hopefully next year you'll get to hear a whole lot more about that. So where Google comes in for us, honestly, is scalability. As I mentioned, we have a lot of data, and I can't overstress that enough. If you want to think of data as a table or a spreadsheet, our biggest collection, if you will, is well over 800 billion, with a B, rows of data. And so that is the data that we chew through every single night when we're doing the behavior analysis. So we have an enormous amount of data, and being able to scale is something that's important to us. Being a big school, it's important, but especially when it comes to the AI, AI lives on data. It's a big deal for us. And so that's where Google comes in order to allow us to scale up and do even more than what we're doing today. And at the end of the day, this is a real number. So in the last 2 years, we have identified 34,712 students that needed help that we made outreach to and were able to assist. That's a real number. Those are real people. This is not theory. This is not what we're hoping to do. This is what we've already done. And these students didn't know they needed help. They hadn't got a grade in the class yet. They hadn't taken a test yet, but we knew they needed help, and we were able to reach out to them and do something about it beforehand. So with that, I'll turn it over to Eddie.
All right. Thank you very much for your time. I appreciate it. My name is Etienne Pellepret. I'm Director of Product Management at Unizin. About 6 years ago, 4 CIOs from some Midwest research institutions were kind of noodling one night over what they were commonly observing in the digital ecosystem to support teaching and learning at scale, and they were starting to see a lot of pieces come together: an app ecosystem, standards, bodies, teaching and learning practices, leveraging design content. But being the research institutions that they are, one thing kept coming back to mind, which is that this growing digital ecosystem for teaching and learning was going to converge the learning sciences with the data sciences, and particularly machine learning. And the question is, how were they going to harness that? How were they going to create the research foundations for the merging of the learning sciences and data science and machine learning, and particularly to investigate new theories of learning? Does anybody know what this is? It's a Hadron Collider. So if there's one thing I want you to come away with from this presentation today, is that higher education needs its Hadron Collider. And the thing that makes a Hadron Collider so cool is that it made things that were once untestable, testable, right? Theoretical particle physics for 60 years has been purely theoretical. And what the Hadron Collider did is take all those predictions from theoretical particle physics and make them empirically testable. That's what we need in higher education. At Unizin, we call our version of the Hadron Collider, or whatever version of the Hadron Collider is going to materialize for us, we call that the world's largest learning laboratory. A laboratory that is for the systemic and systematic study of theories of learning. That's what we really care about in this growing ecosystem for teaching and learning, is the ability to develop new theories of learning and to test deeply new theories of learning. So I want to talk a little bit about how we are doing that. Unizin is a higher ed consortium. It's got about 25 institutions. The vast majority of them are research institutions. Data, analytics, and research is about 1/2 of what we care about and what we do. The other half of what we do is build this ecosystem into which teaching and learning practices are going to scale digitally. So what we've got today is roughly 1 million students. It depends on how you count, but we've got about 300,000 courses running every year. Hundreds of digital learning tools are in use every day to design digital learning experiences, to deliver digital learning experiences, and that is just scratching the surface, because most of our students today get a little bit of their higher education through digital technologies, but in 5 to 10 years, it will be primarily in this natural digital ecology that you can study from a research perspective. So Unizin is creating a teaching and learning ecosystem, and it also wants to study it. So how do you do that? How do you study theories of learning in a digital ecosystem for teaching and learning? Well, you need data. And you need data that's generated by all those apps that are facilitating the design of instruction, the delivery of learning experiences, the measurement of those learning experiences. So with Google as our partner for the last year, we've been building what we call the Unizin Data Platform. Right, that's our foundation for whatever turns out to be the world's largest learning laboratory. And one of the biggest challenges we've actually had to solve up front, thinking about how we're going to found or refound this research field that converges data science and the learning sciences, is how to bring data into the lab. Oh, that's a terrible, am I here? Yes. So this is my poor attempt. Those boxes on the left describe different types of systems you're likely to see in a digital ecosystem for teaching and learning. And there's my terrible description of how data gets into a lab with Unizin. So when you talk to the research community, particularly in the learning sciences, not data science, not machine learning, but in the learning sciences, and you ask them what data matters, they're going to say, I need to understand learners, I need to understand learning environments, and I need to understand their learning experiences. And generally speaking, in the learning sciences, you construct experiments by designing particular learning environments, understanding what kinds of learners you're putting in those environments, and measuring their experiences as they unfold. That's how you test theories of learning, right? Because behind any design or instructional design is a theory of how we learn. Now the problem is that you don't get apps, you don't get data from these apps in the ways that correspond to the kind of data that researchers want. They want foundational data about learners, demographic data, socioeconomic status, race, gender, ethnicity, the kinds of things that social sciences have said are always important to predicting various kinds of behaviors and outcomes. They want curricular data, course design data. Instruction is an intentional act. Right? Courses are designed, learning experiences are designed, and the more you understand that design, the more you understand the context in which behaviors and learning experiences unfold. You need behavioral data, those trace streams of events that are generated by apps that capture something about how learners are learning in the moment they're learning somehow. So when you talk to learning scientists, the stuff on the right is what they say they need. There's a bit of a mismatch and a gap because you can't get exactly that kind of data out of those tools on the left. I apologize for my terrible visualizations. This is the extent of my skill, but the punchline here is that one of the things we've had to solve and grapple with at Unizin in building the Unizin data platform is reconstructing the phenomena that learning sciences wants to study. Reconstructing what we call a unified portraits of learners in their learning environments, which is difficult to do because if you're designing and delivering educational experiences through many different applications and aggregating the data from those different applications, you're getting just bits and fragments and pieces of learners and learning environment design and those learning experiences. So you've got to reconstruct them. So what that means for us is doing two big things every time we ingest data from these apps, whether it's event data or bulk data or pulling data out of APIs. We translate a set of meanings about learning and learning design that are local to those applications into a common set of meanings. Right? We commonly model the data that we bring in, all of the data that we bring in. The second thing we do is we coalesce and we join the data as much as we can. So data about a particular learner is going to be distributed over, let's say, N systems. And each of those systems is going to have their own records for that user. When we bring the data from those N systems into the Unizin data platform, we join all of that data into one single representation of that learner to the best of our ability. But again, the goal is to get a unified portrait of learners in their learning environments. Summarizing this, data is coming into the Unizin data platform from across the teaching and learning ecosystem, the student information system, digital learning technologies, CRMs, the learning management system, and we commonly model all of that data to create single, unified portraits of learners, of learning environments and their design, and of the learning experiences as they unfold, and that creates the conditions to do true, deep learning science research into how we learn. The other thing we really care about is enabling a scientific community. Again, this is sort of a, not quite a moonshot project, but we definitely think about this on the order of 5 to 10 years. How do you enable a research community, right? How do you enable, in other words, the systematic and systemic study of theories of learning? We have a consortium, we have 25 institutions, and what we're going to be doing over the next year is implementing Unizin data platforms at every one of those institutions, connecting all the tools from their digital ecosystem for teaching and learning to the Unizin data platform, and aggregating and ingesting all this data into a single common data model. That creates the conditions for an experiment run at University A to be reproduced at universities B, C, D, and E. Or an analytical model or predictive model to be developed at one institution and tested at other institutions. You need a way of consistently unifying the data that you want to study in your laboratory. So why are we doing this? We're doing this because while machine learning capabilities and data science capabilities are pretty amazing, we have found that to scale a new research field, you have to think pretty long and hard about how you bring data into a laboratory environment for experimentation. It's really hard to do. Research projects generally require a lot of upfront lift to massage and clean data to run experiments. How do you do that a million times? How do you do that a million times at scale across an entire scientific community? So bringing in data is going to be difficult, but cleaning, modeling, unifying that data is what we are focusing on right now. We also think that this research community is not naturally going to emerge, so we're going to catalyze it through our consortium. Again, running lots of experiments through commonly modeled data across institutions in the consortium. And finally, this goes back to the two halves of Unizin as both educators building the ecosystem for digital teaching and learning and researchers studying theories of learning. We think there's a pretty strong virtuous circle between informing the research with design and informing what research needs with the designs themselves and how apps and vendors build their applications. So with that, I think Tracy, yes.
Okay. So I recognize I'm standing between you and your burning questions for these awesome folks, so I'm going to try and go really quickly here. And I want to talk to you just a little bit about Cloud AI, which is part of the Cloud Group, and how we can help you bring AI and machine learning into your own environments. So technology, as we saw, is obviously really only applicable and helpful when it can actually be used. And this sets up what is actually the biggest challenge that we have in the world of AI. So historically, I mean, AI has been around for 60 years. But it has really been walled off into a very small portion of the population. So folks who have advanced degrees in deep learning or groups of people who have been studying data science for a very long time, it hasn't really been able to be used by the large number of developers or the large number of people who are working with data every day, all day. And that's something that we think about a lot. Because the reality is, this is our biggest challenge, and it's also our biggest opportunity really collectively, not just within cloud. And it's because of four big reasons. One is that because of the fact that it's been limited to such a small part of the population and nobody really understands exactly what they're doing, it's got a lot of mystery associated with it. And that leads people to think about, draw their own conclusions about what AI might be able to do for them. And in reality, there's a lot of things that are very practical and tactical that can have real impact into your organizations that don't get thought of first. And so we really want to make sure we're helping with that. Because of the fact that you have just this small group that's been able to build machine learning models, most of the examples that exist in the places where there are really robust solutions in organizations have been built in-house. And so they are not something that can be replicated across other organizations, making it really hard to scale. You have a lot of inconsistent deployment. The vast majority of machine learning models that get built never come out and see the light of day. And a lot of that, again, has to do with the fact that you have to really think about the entirety of the workflow of that model and that solution. And if you aren't thinking about that in the beginning, it's very hard to then break that into the places of an organization who need to access that model and be able to benefit from the help that it's giving them. So this creates this whole world of a lack of examples where you have this sort of flywheel around this this challenge that we face where we really have an incredible opportunity with the technology we have, but it's a lot of detective work in terms of figuring out what are the right things for us to focus on so that you can really leverage machine learning. So that's our vision in our group, and you heard a lot about this from both Fei and Raja and Sheth yesterday and today, but we really focus on democratizing AI by making it easy and fast and useful for our customers and our partners. So I'm going to give you a quick snapshot of what we cover, and then we will open it up to questions. So we break our products into 3 areas. We have our platform, which is a lot of what these folks are using. That's our cloud machine learning engine. It's the place where we really want, if you're doing data science, if you're doing machine learning, we want that to be your home. We have a set of building blocks ranging from our pre-trained APIs through our AutoMLs, a lot of which we launched here, which we're really excited about. And then increasingly, we're working on a set of solutions that are industry-specific. Contact Center AI, which we announced yesterday, is one of the first of those areas that we're tackling. So within our platform, we really want to cover everything from prototyping to model management. It's multi-framework, easy hybrid deployment. There are a lot of pieces of the puzzle here. And for those of you who want to build large-scale models from soup to nuts, this is a place where you can come and do that. And we handle a lot of the scaling pieces for you. From our set of building blocks, this is that set of pre-trained APIs. These are not customizable, and that was one of the things that really led us to AutoML, because while these have incredible applicability into organizations, oftentimes you need your own data to be a part of any solution. And so how could we do that in a way where we really could open up access and make that available to anybody without machine learning expertise? And AutoML really, really does that. As you saw, we have now vision, natural language, and translation, and there's more to come here, which we're really excited about. And essentially what this does is it's a machine learning model that creates machine learning models so that you can, oh, I skipped it, but it's okay, we only have a couple minutes. So now let's talk about solutions, because this is where it's really applicable to you guys. So this is a set of verticals that the cloud organization is really thinking a lot about. And so we are, as part of the AI group, looking at each of these industries and saying, okay, what is the technology that we have? Where can we partner and work with customers to really have deep domain expertise if it's something that we don't currently have? And then how do we bring all of that to bear to create solutions that we then scale out through partners into the market? So we're really interested in hearing what some of your challenges are, what problems you're trying to solve, so that we can make sure that we're building the right things for you. You probably saw about a month and a half ago that we released a set of AI principles. And this is something that we think about all the time, every day, because it's an integral part of how we work. And we're working really to infuse this in all of our products from the beginning, right when we start development, all the way out through the ways that we help our customers and our partners really leverage this kind of experience. And you can see some of this today. In AutoML, we actually built an inclusive ML guide to help you as you're building your models. It's connected to the UI, so you access it within the product. There's a lot more to come here in terms of testing and transparency and tools that we want to offer you and the ways we want to work with our customers and partners. And so we're really excited about engaging in this process alongside all of you.